1st of July, NASA detected a mysterious object speeding toward Earth, and some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all.
What if an interstellar object whirling through our solar system is actually a nuclear-powered spacecraft sent by aliens to test how humans respond?
In the vast silence of space, our solar system is not a closed-off island. Every so often, fragments from distant star systems drift across the endless void and wander into our cosmic neighborhood. Most of these pass unnoticed, never discovered by human eyes. But in July 2025, astronomers spotted something that changed everything: an object on a hyperbolic trajectory, moving too fast to be bound by the sun's gravity. It came from the stars beyond. Its official designation is 3I/ATLAS, the third known interstellar visitor after ʻOumuamua in 2017 and Borisov in 2019. Yet this object, unlike the others, has raised more questions than answers. Its strange orbit, bizarre chemistry, and perfectly timed solar disappearance have fueled debates not just among scientists, but in the wider world. Is Atlas simply a natural interstellar comet, carrying the frozen chemistry of another star system? Or is it something engineered, an ancient probe crossing space on a mission we cannot yet understand? This is the story of 3I/ATLAS, what we know, what we fear, and why its visit could reshape how humanity views the universe. The discovery. On July 1st, 2025, the NASA-funded Asteroid Terrestrial Impact Last Alert System, ATLAS, operating from Chile, detected an unusually fast-moving point of light. At first, it looked like another comet, but orbital calculations told a different story. Its path was hyperbolic, meaning it was not orbiting the Sun at all. It was simply passing through, arriving from the depths of interstellar space. Humanity has catalogued millions of asteroids and comets, yet only 2 before had ever been confirmed as interstellar. To find a third within a decade suggests that the galaxy is far more filled with wandering objects than we once imagined. But what made Atlas special was that almost immediately after its discovery, it began to behave strangely. Astronomers noticed a coma forming, a glowing shroud of gas and dust usually seen in comets. This led to a double designation, C/2025 N1 Atlas as a comet, and 3I/Atlas as an interstellar object. This dual identity meant that not only had it come from another star, but it was actively releasing material, hinting at volatile ices within its core. But from the very start, scientists realized that this was not going to be an ordinary case of just another comet. The speed of a wanderer. Atlas entered the solar system at a staggering speed of 210,000 kilometers per hour. To put that in perspective, it's nearly 60 kilometers every second. At such velocity, observation windows are narrow. Astronomers must scramble to capture data before it disappears forever into the night sky. Hubble images added another twist. They suggested the object's nucleus could be anywhere from as small as 320 meters to as large as 5.6 kilometers across. This wide uncertainty comes from how brightness is interpreted. When sunlight reflects off a comet, its glow depends both on its size and on how much dust it sheds. Some researchers proposed that its strange light profile could even suggest self-illumination, the idea that ATLAS itself was producing light rather than merely reflecting the sun. Avi Loeb, a Harvard astronomer known for his provocative theories, argued that the steep surface brightness profile looked suspicious. If true, it would mean ATLAS carried its own source of energy, chemistry from another world. If the brightness raised eyebrows, the chemistry raised alarms. Using the James Webb Space Telescope, astronomers analyzed the light coming from ATLAS's coma. What they found was extraordinary: a ratio of carbon dioxide to water nearly 10 times higher than what's seen in most solar system comets. This means Atlas likely formed in a region far colder than where our comets were born, perhaps beyond the carbon dioxide ice line of its parent star's protoplanetary disk. The presence of silicate-rich dust and pristine water ice further confirms that it comes from a place with chemistry different from our solar system. For scientists, this is thrilling. Interstellar comets are time capsules, carrying frozen relics from alien worlds billions of years old. But for others, the strangeness of ATLAS's chemistry adds fuel to speculation. Could this be engineered material, cloaked in ice and dust, disguising something more? The unlikely path. ATLAS is not wandering on a random trajectory. Its path is retrograde, moving opposite the planets, but tilted only 5 degrees from the solar system's plane. The odds of such a shallow inclination happening purely by chance are tiny, less than 0.2%. Even stranger are its planetary encounters. In October 2025, Atlas will pass within 29 million kilometers of Mars. To many, this is simply cosmic coincidence, but to others, it is unsettling. If Atlas were guided or designed, its trajectory could hardly look more suspicious. The solar blind spot, perhaps the most unnerving part of Atlas's journey, comes at perihelion, its closest approach to the Sun. ATLAS will slip into solar conjunction, disappearing behind the Sun from Earth's perspective. Ground-based and space telescopes alike will be unable to observe it safely. This is precisely when the comet is expected to be most active, shedding dust and gas in dramatic fashion. If any unusual acceleration or maneuvering were to occur, Earth would not be able to see it. Avi Loeb and others have described this as the perfect opportunity for a reverse Oberth maneuver. Is this simply a coincidence of geometry, or the most well-timed vanishing act in cosmic history? The debate intensifies. Within the scientific community, debates rage. Most astronomers see ATLAS as a comet. Strange, yes, but still natural. Hubble images show a teardrop-shaped coma with a faint tail, classic signs of sublimating ice. Models of dust scattering explain the brightness. The chemistry, while extreme, can be explained by formation in alien conditions. And the trajectory, though improbable, does not defy physics. History offers warnings. When ʻOumuamua was first discovered, it too showed strange accelerations without a visible coma, sparking years of speculation about alien probes. In contrast, Borisov looked more like a traditional comet. Atlas seems to sit between them, part comet, part enigma. Upcoming tests. The coming months are critical. In October, the Mars Reconnaissance Orbiter may attempt to image Atlas during its close pass by Mars, offering the best resolution pictures of any interstellar object in history. Though the chances are slim, even a few pixels could reveal coma structures, jets, or asymmetries that confirm or challenge the comet hypothesis. After perihelion in December, ATLAS will re-emerge from behind the Sun. At that point, telescopes worldwide will scramble to track it. The Vera C. Rubin Observatory, now operational, will play a crucial role in measuring its brightness and trajectory with unprecedented precision. If Atlas behaves like a normal comet, gradually fading as it departs, the case will be closed. But if its trajectory shows unexplained changes, if it deviated while hidden behind the Sun, then the mystery deepens. For scientists, this is the make-or-break test. Fear and wonder, Scientists insist ATLAS poses no physical danger to Earth. Its closest approach remains nearly 1.8 astronomical units away, farther than Mars's orbit, that humanity may miss its chance to understand it. Atlas will never return. If we fail to capture decisive data during its brief passage, the mystery could remain unsolved forever. If Atlas is artificial, it means we are being observed by a civilization far more advanced than ours. And if it is natural, it still challenges our understanding of how planetary systems form and what debris they eject into space. Throughout history, comets and cosmic anomalies have stirred fear. In the 17th century, comets were seen as omens of doom until science revealed their natural orbits. In the 20th, near-Earth asteroids sparked existential dread before planetary defense strategies were developed. And now, in the 21st, interstellar objects have become the new frontier of mystery. ʻOumuamua baffled scientists with its cigar-like shape and strange acceleration. Borisov confirmed that interstellar comets could look normal. And now Atlas stretches the boundary once more. With each visitor, our models of the cosmos grow, and our certainty shrinks. So what is ATLAS? This question has haunted astronomers, journalists, and the public alike since its discovery. The simplest answer is that Atlas is an interstellar comet, a ball of ice, rock, and dust ejected from some distant planetary system billions of years ago, now passing through our solar system by sheer chance. The anomalies are difficult to ignore. Its string of close encounters with Mars, Jupiter, and the Sun, so neatly aligned that the odds against chance are 1 in 20,000. Its unusual chemistry, dominated by carbon dioxide in ratios unlike anything seen before. And if you want to keep exploring these mysteries with us, don't forget to like this video, share it with others who love the stars, and subscribe to the channel for more journeys into the unknown. The universe is full of secrets, and together we'll uncover them, one story at a time.